This is where the Bifrost under curriculum ends and we start talking about actually going out to game engines in a more serious fashion. So some of the things, before we go into that, some of the things you should take away from here are, these guys are loaded in as prototypes, basically. So they're just referenced from a file and then they're put into a scope. And that's really so that we can just have these here. And the only difference between the two is that that has no layer offset and that has a layer offset of 20, which of course I can go in here and change to 40. Back up a bit, play again. And you've still got all of that control. Prototypes are what an instancer needs. So this is why you can't just drop a Maya mesh in without a defined mesh. Now you're fairly familiar, I mean, you should be fairly familiar what an offset is, a time offset, because we're going to be getting into that deeper in the next section, as well as how you would write out an animated file and some of the things you need to do in there. So why don't we just get right into it? Okay, so you will need to open the Vertex animation file. And you should see something like this. Now, this is the USD. This is an NPM cache, and that cache lives in the folder. So if I show you the folder, there's a thing called Bobcache in here. This is where you get the cache. I'm going to take you through this file first, and we'll talk about actually setting it up. So this is a little compound I came up with, which allows you to loop a cache endlessly. And the way it does it is basically, this one is set up so it'll work with both Alembics and with Bob caches. What this does is it takes the frame, offsets it by half as much time, right? So you got the start frame and the end frame coming in. It does a bunch of maths. Feel free to go through here and take a look. You can just take that out, that's fine. And then you've got normal time and phase time. And what happens is you are reading the cache. We're just going to look at the Bob. The ABC is similar, but slightly different. We're reading the cache at that time. So this would be frame 0, but this, because this is a 128 frame animation, this would be frame 64. So you're reading the cache at half as much again the time. And the cache is 512 frames long. All it's doing is it's looping the two together so it never pops, setting the point position, updating the mesh normals, and then the rest of this is logic. So what you end up with, if we just go out of the loop cache, and I'll break that so we're not looking at the USD, I will put in the terminal. Now something you might be noticing is that we're edging closer and closer and closer to basically making a tool here. This is very much a compound that can be used as a tool. This is a compound that can be used as a tool, and so is this one. Reset our cache and see what we get. Oh, maybe we need to unhide our Bifrost there. That might be a good idea. So this is what the cache comes in like, okay? And this is not looping at the moment. This is just playing the cache. So if I set this guy to loop, continuous there, and you watch when it hits over 128, it's going to, I am playing the loop cache, I'm sorry. If I was to just play the cache, so that would be probably this guy. Let's grab this guy, pop that out, and we'll just play it at the end, pop. So what the loop cache compound does, and I'm giving it to you guys for free so you can work out how it works and see a more mathy sort of approach. It's based on a game shader idea as to how to take, this is based on UV looping, which you're all familiar with. I know you're all familiar with, and how to work a flow map. I'm just, instead of outputting it to a flow map, what I'm doing is I'm outputting it to a set of point positions that are changing on this object. And you can see as it's now looping seamlessly, because I've set up the start frame I want, the end frame I want, where my cache is. Dig in and have a look. But the concept of looping, especially for going out to an engine and or using in a game engine, you maybe in a couple of years it'll be okay to just real-time simulate something like cloth. I mean, NVIDIA is doing amazing stuff and things are moving forward very fast. But right now, this is an easy way for you to get a low res cloth out in loop. And what does that is how we get things out to a USD animated mesh. So this is a very fancy one. Okay, I've made this fancy. It's got bells and whistles. It's because we're in week 9, we've got one more lesson to go, and that lesson is tool creation. So today is all about how do we get Vertex animation out to a game engine through USD, which is what we're doing. It's also about trying to build a little bit of a Bifrost bridge, what you need to know to get things from Bifrost to Unreal, to Unity, to whatever it is you're using. So this one's a bit fancy, but we'll quickly rebuild it. Really what you need to see in here is this has a lot of integrity checks. Okay, so this here means you can plug anything scalar into this port. This means you can plug anything vector into this port. It's things like that. It's a little higher level than we've been doing for the course, but I'll show you how it works as we go, and I'll explain it how it works as we go, but it's so that next week when we sit down and we build a tool that you could give to a Maya user in a studio, you could give to an environment artist, that you have a better idea of some of the things you actually need to think about when you're building a tool. So I'm going to give you both this one, and then we're just going to rebuild it. Maybe not quite so fancy, but this one, just so you know, this one will take in your animated mesh. It'll also take in a static mesh. If you want to have a static mesh as well, like a flagpole on that flag, you could put that in here and it would output it into an animated USD file without animating it, thereby saving you some time. And I'm going to show you, before we get started, I'm going to show you how an animated USD file actually works. But this as a tool takes in an animated mesh, and a static mesh, and a stage. Then you need to tell it how many frames you want, what frames per second it is. This is your scaling, Bifrost to engine ratio. What this basically means is on output, what size is each of these squares? So I'm working in Maya, I'm working in centimeters. Each one of those is 1 centimeter by 1 centimeter. If I was to come over to Unreal, you see I've loaded a flag. Each one of the grid units in Unreal is 1 meter by 1 meter. So what that is doing is it's telling you, in fact, it's badly named. Why don't I just change that? Something like output unit size. So this is 1 meter that we'll be doing. So output unit size in meters. There we go. Not the best example of a tool. Would have to come up with a better name, but you've also got, you can save your USD. So this is incorporating right down the end here your save stage. Now it's a bit special because of the way animated meshes work, but if that's turned off, this won't output. Okay, that's where you're saving it to. That's the name of the mesh. This is called flag loop. I've called it flag loop. But if you look at the USD proxy, and this is set up for the way that I want to go out to Unreal because this is how I work. You don't have to work this way. That's where it's called flag loop, but I've also made sure it names itself flag loop asset on its parent transform. So again, stage, first parent, and then I've got 2 scopes here, one holding the geo, one holding the material, and then the geo and the material itself. In this case, I'm using a texture. You can set an animated texture on this, which will, if your vertex color coming in is animated, you turn that on, and I'll show you how that works in just a minute. Then I can say load a texture file path. As you guys all know, I'm from New Zealand. That's the flag of New Zealand. Why not? I ran out of inspiration that day. And then you can tell it to use texture or not. So we'll turn that off. And what you've got there is this color ramp. So that's what that color ramp looks like. That light's possibly a little too intense right now. So this is this ramp coming in. Now I can disconnect that. It'll just go gray. I can make a value. We'll set that value over to vector like that, and let's make it bright freaking green. And we'll plug that in here. And this is what I was just quickly showing you before. This will take anything that's a vector. This will take anything that's a scalar. And I mean it. If I put a fractal turbulence field in there, where I have made an absolute value, this is all stuff you've done before. And then I plug that into the vector, then I'm going to get a nice random color. So you can kind of see how that works. Well, you can't see how it works because I haven't told you how it works yet, but that's what that's doing. That's the vertex color in, that's the vertex alpha in. So this will output RGBA, it will output RGB, it'll output the texture ready for USD. And then you just, whether you want to use the texture or not use the texture, pretty simple. Plug the ramp back in like that. Let's turn on use texture, turn on not use texture, and it's still saving. So how do we get, how does USD animation work? Okay, let's just break that. So we got nothing, and we'll turn our terminal back on so that we've got our cache. So this part of the lesson is all about vertex animation. I have just used a cache because I don't want to sit here and simulate a flag, an NPM cloth all the time. We did that. Cache it and use it, right? If you followed along the lesson properly, you would have cached it already. So just use that cache. Use a Bob cache for that. It's all pretty good. And that's literally what you've got coming out of Bifrost right now. So how do we output this to USD? Well, let's take a look into the example here and we'll get the basics. Very first thing we need to do, very first thing, is we need to define a USD mesh, right? Just like we've been doing before. So I will move these, and I'll break that for now because I don't need them for now. I just need that one for reference. Just move these out of the way. I'm going to need that. I'm not going to need that. So before we do anything else, we need to define a USD mesh, because if it's not a USD mesh, USD is not going to play well with it, is it? Define USD mesh, right? So, and I'm going to show you how this is all connected to the tool settings as we go. Because yes, it's about vertex animation, but also I need to get you ready for tool construction. So define USD mesh. This is making the mesh, and we need to give it a unique name. I'm going to call it flag. Not all that unique, but we've only got one object. We're outputting one asset. We haven't made a tool out of it. Everything else is pretty much okay. We've got no variants. We've got all of this kind of stuff. So we're going to need a mesh. There's our mesh. And because we want to see how this is working, let's just add it to a stage. You know, because yes, we can see the Bifrost over here. That's this guy. We'll turn him off. But we'd also like to see the USD. So we'll pop that into the output. There's our flag. Better show that. So there we go. If I'm just going to really quickly set up a switch because we would like this to switch. Let's put that into the true and that out. So it's going to disappear. Let's make a value node here. So we've got a true or false value that we could use. So at the moment, we're not showing our USD. And what I want to happen is that if we're not showing our USD, I would really like to see our Bifrost, right? So we just put in a not. So now if that's false, that's true. If that's true, that's false. And I can just put another if in here. This is just a really simple kind of OR thing. You'll only ever see one or the other. Turn on our display and plug that in, right? So here's our Bifrost. Here's our USD. You can see our USD proxy shape is empty. We don't have the hierarchy we're used to until such time as I switch that over. There we are. We've got our flag. So let's look at the Bifrost and then compare it to the USD. So this is what's coming out of the loop cache that I made, right? Let's turn the USD on. And that's what's coming out of the USD. So everybody's happy. That's doing its thing. It's reading this, defining it as a mesh, and adding it to a stage. That's absolutely most of the job done. This is vertex animation. Each vertex here is animated. Normally, to get vertex animation into a game engine, you would need to do a vertex animation texture or something like that. This right now is not going any further than that. There is no save USD here, nothing. It's just we're seeing if it works, right? So what else do we need to do? Well, I don't just want to put out something called flag that has nothing. So what I'm going to do is I'm going to add a couple of things. I'm going to add a scope here. And I'm going to call that scope geo. And I'm going to pop that into the children and then make sure that is set to scope. that's really just for making a group into the stage. So let's take a look at the stage. Make sure I replace it, not just add it on top. So there we go. There's our proxy shape, that's our stage. There's our scope, and there's our flag. Perfect. I want to make another one. I want to make a scope, but this time I'm going to call it mat for material. And this is where we're going to put our materials. I'm going to take an attribute definition, USD preview surface. This is where we're going to load our flag. That goes into the children of that scope. Yep, that's the material scope. And then we just pop that into the stage as well. I'm just building this a step at a time. We can take our preview surface and we'll, let's call that NZ underscore flag. Like that. NZ flag, there we go. Cool. Not seeing it on there, so we need to make sure that that's working. And again, just building this slowly and using this build to demonstrate not just vertex animation, because it's going to get complicated. That's why I'm doing it slowly. Not just vertex animation, but how to set this up so we can do it as a tool later. So right now we've got two scopes, geo and mat. The flag's in the geo, the mat's in there. We're going to need to bind that material like we've been doing. We need our primitive path. Let's do that the way that we've learned to do it. So we'll go to the attribute editor here, go to our metadata, there's our primitive path, and go back to Bifrost. Now, this is going to change. I want to put an asset that these two go into. So if I bind this material now, that binding is going to change. Absolutely going to change. So let's actually put in our asset now. So that's a transform. And the reason it's a transform is that I might want to move it. I might want to move everything in it. And this is where I got the name asset flag. And we just simply make these guys both children of this. And then I'm going to break those connections. And I'm just going to add it to the stage. So now if you take a look, you've got asset flag, geometry, material. Lovely. Now I just so happen to know that this guy absolutely has UVs on it, which is why all of this works. That's fine. The UVs are on the cache, so it'll work for you as well if you've got the material loaded. Now I can bind my material. So I can go into geo, take the flag, go to my attribute editor, copy that, go back to Bifrost. That's my primitive path. That goes in there. And then I can go over here, attribute editor, copy that, back to Bifrost, and that's my material path. All right. So let's output that. See what we get. There we go. Our flag is on. This is one option for our users, right? What happens if we want to just do color? So let's change the name of this so it's a little bit more straightforward. This is the one with the texture. Now you see how my bind material broke, but this has changed to texture. Okay. So there are cool things you can do with strings here where you can actually set that to change. And also a relative path system that I haven't quite worked out. I'll replace NZ flag with texture. So now it works again. So that's just a naming. So now what happens if I just want a color? So define USD preview surface. And let's get sort of a nice bright yellowy color going on here. And we can put that into the material as well. So now you can see texture, and let's call this guy yellow. Now, if I want to switch those over, all I've got to do is come over here and switch it, and there's a yellow color. This gets a little bit different if you want to add an array. Okay, so you want to add an array of colors, a ramp, for example, like we have been doing. If I take the preview surface, copy and paste it, take a look at how it's actually doing it. Now, this gets quite complicated in here, but basically, if you follow it down, you're going to get to a point where you've got define attribute here. So this is defining your diffuse color. And the diffuse color, if we jump back out, is what we're putting our yellow into. So you can, if you want to, go in here. And you remember when we made our own basically a new attribute. So this in the surface shader here, this is just a define attribute. We can make our own attribute. And we've done this before, right? So we just need to copy what's going in here. But this time, instead of just color 3F, we can do color 3F array. So this is an array now. Enable the value. We can change the value type here to set the value type here to float3 array. Just like that. That's all cool. Enable the primvar, because we want it to be a primvar. And then primvar vertex. So that's per vertex now. And yes, I'm absolutely cutting up a Bifrost vanilla node to do this, but we need to find where that attaches, and we need to attach our own instead. So I'm going to pop that in there. And we need to make sure that what's coming in is also our one. So the value is diffuse color. So I can pop this in here and say diffuse vertex. I could maybe spell it right too. Just while we're playing with it. And then there's one more connection here, which is enable connections and target prim, right? So enable connections, we'll pop that in there. Target prim, we'll pop into target prim, which is all good. And that was all that was connected. So I can delete that now. Let's see if this worked. I'm going to go in here. I'm going to call it vertex color. Okay, and I'm going to pop that into the children. You'll see it'll turn up here as a shader. That's precisely what we want. And we're going to need to actually provide some kind of vertex color here, something that changes. So for now, I'm just going to use a random value array like I did before. So we'll take this, we'll need the point count. There's our point count. We'll need a random array, random value array. This is the size of our array. I'll need this to be a math float 3. And this is just going to generate an array between 0 and 1, which is perfect for vertex colors because that's what they are. So what I forgot to hook up here is I haven't made my connections back out to the shader. I've made this one, diffuse vertex. And if we just make sure we're showing all of the ports, there's diffuse vertex. Let's pop that out to the beginning as well. Now, let's just see if this has actually worked. So we'll pop that into there. So this has just now become another shader in the material. If we come over to where we bind our material right here, instead of yellow, what did I call it? Vertex underscore color. So instead of yellow, moment of truth. Didn't work. Let's see if we can find out why. So I've been away and I've come back and I've found out that we actually can't do this. I'll come back with a method that actually does work. Okay, so if we want to put vertex colors on this, which is very important for games, very important for game, like you need to be able to read the data off the meshes coming in to make shaders based on it, basically. That goes into a different place. That goes into the attribute definition here. And we do it by using a USD display color, but our own version of, which we've already made one of. So these will work for materials. That's a yellow material, and that's just color with these settings. That one has got a texture in it. That's fine. We can use this, and we can build a statement later on to tell us what we want. But to actually affect the per vertex color, that needs to be a display color here, like we've been doing before. But it can't be this one. This is what we were talking about before. So what it needs to be is a display color that will take an array of colors per vertex. So let's get that done. So basically we just need to set this up like we did before. Display color, color float 3 array, enable the value, primvar per vertex, and enable primvar. That's all we're going to need right now. And we can just use the array that we've had here. So that goes in, and there we go. That's a random color array. What we need to do is enable and disable this. So let's take this back to texture. So we know we can swap between the texture and the vertex color, and the way we do it is, and this is a bit more of the tool setting than anything else, is we're going to put an if statement in here. So basically, if we want the texture, we'll need to set this to true, and it'll default to the vertex color otherwise. So this is basically going to bind a material or not, based on what we say. Sometimes you will want to bind a material, sometimes you won't. Okay, so now this is going to be set up as an option later on when we make this a tool, if we want to make this a tool. I'm not actually going to show you how to make this a tool. That's going to be your homework this week. I'm going to teach you about vertex animation now. Okay, so this has basically just got us to a USD point that we like. Okay, so here's our asset. It's got a name. It has some scopes as groups in here it's got some shaders. It's also got a vertex color going in. It's binding the material or not. Everything's cool. Now we need to talk about how do we get this out to USD? Well, you might think that just straight away, we've got a USD output. Why don't we just do a save stage? Save USD stage. Let's give this a place and time. It's going to be, so we'll put it in our USD directory. You have your own, as I keep saying. Save new tutorial dot USDA because we want to look at it. There we go. And we'll enable that. That's saved. Let's check our meters per unit to 1. And let's jump across to Unreal and open that. We'll just load that stage. Flag new tutorial. There it is. Now, let's just close that up and close that up. Go to our stage actor. Let's have a look at our level sequence. It doesn't look like there's any animation in here, and there's not. We haven't output an animated vertex. We've output basically frame 0, or whatever frame we saved it on, 39. If I go back to frame 0, and then go to the USD stage, and reload it, there you go. So now we've got frame 0. That's all that. And my shader's not double-sided, but that's okay. We know how to work that. So that's what we need to sort out to get vertex animation into Unreal. So let's get going here. So the trick to this is USD wants some information. And the way that USD writes out an animated object, a vertex animated object, is it will write the position of every vertex on every frame. Makes for some big files. But there's a way you need to set that up to do it. So if you look at what we've already built here, you need a couple of things. You need an animated stage. That's there. You need set stage timecode, which is here. And you notice the animated stage, which I'll just copy that, isn't actually a compound, okay? What animated stage is, if I paste this here, and we take a look at it, it takes in a USD stage and it adds something to the stage and then it pops it out. But it's a loop. It's an iterate. So this input is this output, and then it goes through again. So what this is actually doing is adding each frame's mesh to the stage. Now you don't want to write this every single time because again, you'll just write one frame. You'll end up with the last frame because it will just write one frame. Or it'll write one frame and then 2 frames and then 3 frames and then 4 frames, and you'll end up sitting here for hours. So we need to put in a little bit of logic here. So here's our stage coming out and going into the save stage. Pops it in there. So this is why, if you take a look at the tool here, it has number of frames in it. What the number of frames is going to do, let's put down a value and change the name mode, and a float is fine. Number of frames, we'll set that to 128. Okay, so obviously we're animating something. How's this going to do? And what are we adding to the stage? Well, where's our add to stage now? Our add to stage is here before the bind. So let's take out the bind just for now. We can put it back in later. So that's just going to give me whatever vertex color I've set on this, which in this case is an array of randoms. So we can do the binding again later. We know how to do binding. So what we're going to need is a time node, right? And a time node, you know what the time node does. It just basically tells you what frame you're on. So you want to make sure that this is equal to this before you do any writing, okay? Before you do any saving or writing out to disk or save the stage. So that's just another if statement. We're having a very logical day, all right? So if that's true, so if the time is equal to the number of frames, then we want to write our animated stage out. Trouble with that is you're not going to see anything. You're not going to see anything at all because that's only going to come through when it's true, right? So what you want to do is also put this into the false. So right now it's not equal to, I mean, we can actually do the save stage now, I think. Because, well, we're going to need to put in something else first. Set stage timecode. So let's double check the tool that I've already made. Where does set stage timecode come in? It comes straight after animated stage, and you can see the same system here. This is the add static mesh part. You don't need to worry about that. This we'll talk about in a minute. There's the binding. This is the if statement. No, that's the texture if statement. This is the equal we just did. So this is our main if statement here. Okay, so it's the same thing. If it's not equal to the number of frames, it's just going to output whatever is happening on the stage. But if it is, it's also going to save it and output it. So it's only saving it at the last frame. So you have to play it through to get it to save out an asset, which isn't too bad. So let's add that in. So here's our animated stage, set stage timecode. There's our animated stage there. What this does is it writes super important information out to the USD file that the USD file needs to know that it's animated. And what it wants is what frame you're starting at and what frame are you ending at. And that's pretty easy because we have a number of frames here can just pop into the end and the start can be 0. You can put that out as an option as a start frame or whatever. And then we just drop that into there. So we're going to run into trouble because we're already adding it to the stage and then we're taking the stage out through a bunch of its statements, which is all about, you know, this is if we want to see USD or not and all of that kind of thing. So let's just really quickly tidy that up. So I'm not going to need that anymore. That can go. Everything's going to break for a second. Animated stage is definitely going to break because it wants a USD stage in there. And that's all not happy. That's all not happy. So we'll really quickly rebuild this. So this is what we're adding to our stage. This is our stage. Okay. So we've got this whole infrastructure going on up here. First one we need is let's get this animated stage down. That goes into the stage and that goes into what we're adding. So that's what we're adding to the stage, right? Then we need our time and our if statement. So we'll bring our time down here and then we can do the thing where we just go like, okay, if the current frame is the same as the number of frames, just like that. If that's true, then we want to write the stage that we're saving the stage. We need to break that as well. And we're just going to save the stage. We'll keep all our names and stuff like that. But if it's not true, we still want to see what's going on. We just don't want to save it. So now if I take my output, put this back in, then we've got our flag. It should still very happily move, and it does. But it's not until we hit the end here. Looping once. We don't want to keep looping and keep saving. It's not going to hit the... It's not going to actually save the stage out with its time code and its animated stage where it's adding each frame to the stage. It's not going to put any of those out until it hits the end of the animation or the number of frames you tell it to. So let's just play that through once. There we go. And once more, we've still got no animation here. There's nothing coming through. So what we're going to do is just take a quick look at the ASCII file. So these two here are what the set stage timecode puts in. And you can see that my start timecode is 0. My end timecode is also 0. So there is no animation in this file. And the reason for that is I need to put my number of frames into my end here, and then I would manually set this. So I would say, okay, I want to start at 5, or I want to start at 1. Whatever your file is set up to do is what I would put in there. So let's just play this through once again because it needs to resave and build its iterations. We'll just okay, and let's see if it's any different now. USD stage, reload that. Well, we have animation. End timecode is 128. That's all working, but we're not saving anything. So here's our materials, here's our flag. Our points are just a single unit. It's a big array, but it's a single array. When we have an animated file, we should have each frame for each one of these, depending on what's animated, and that's the problem. USD does not know if we want to animate this yet. So what we need to do is come back to where we've actually made our flag. And you see you've got use frame and what the frame is. This is how you tell USD that it's animated. So what we're going to need to do is take our time node here and hook it up to our mesh, which is up here somewhere, I think. There it is. Define mesh flag. And we need to plug in the frame to this frame here. You see the connections made. So the frame is going to go 0, 1, 2, 3, etc., etc., etc. And it's going to write out to the defined mesh 0, 1, 2, 3, etc., etc., etc. We need to turn on use frame. So once that's turned on, this should in Unreal be animated. Let's check it out. So we'll play it through so it writes out. It's running real slow. Not looking all that good just now. And there you go. It's saved. Let's go back into Unreal. Go to the USD stage and we'll reload it. There we go. It seems to have shrunken to the ground a bit, so I'll just move that up. Here's the sequencer. If I press play, and Unreal crashes, but it is animated. Unreal is crashing for a reason. That reason is Unreal has no idea what frame rate this USD asset is because we haven't told it. So we need to actually tell the USD, we need to tell Unreal through the USD file what frames per second it has. You know, what is this animation saved at? And you can see in here, we have a frames per second there. What that's connected to is the set stage metadata. Okay, so we can use that. We can just pop that. Oh, where did I put that? Let's have a little look at that. Set stage metadata, where is that at? That is here. So that is happening after the static meshes, but before the write. Yep, perfect. So come back down here. This is the simpler version. Here's our write. There. So set stage metadata. Right now, if we look at the USD file, this is where all of our communication with Unreal happens. Well, so most of it. This is where it says this is my default primitive, this is where my timecode ends, this is how big I am, this is where my timecode starts, and Maya is way up. Now you can see differences. Okay, so there's the time samples. This is the animated. You can see there are 128 of those. Face vertex indices. It's going to be 128 of those as well. So it's literally saving everything out. And it's saving every position, these are the points, every position for every frame. That's why it's vertex animation. This is different from skeletal animation, which you can also do through USD. Bring it into Unreal, and you can actually set up a live link between Maya and Unreal through USD using skeletal animation. But skeletal animation is good for those things that have a skeleton. Animating a flag or grass or curtains or noodles or anything that you really don't want to rig, like an effects animation, that's where skeletal animation doesn't work very well and why we have vertex animation. So we'll come back to here where we're working. We need to set our stage metadata. That needs a stage and it needs a key, and the key is frames per second, and the capitals are important. also needs a value, and that value should be a float. Let's just double check with the tool that I know works. And I am doing this for a reason. It's really good if you're recreating something to have a reference there. It's really good if you're changing something to have a reference there as well. So it's not a bad way to work. Just check that we've got frames per second, frames capital P, capital S. That's cool. Go up out of there, come to the one we've just put down, frames per second. Paste it. No, we can't. And then that is going to go into the save stage there. Now, I think this needs to be a double rather than a float. It needs to be a more accurate variable. Let's just take a look here. Yes, it does. It needs to be a double. So that's easy to change in our setup. We just go back to the metadata, right click, value type, double. And our error's gone away, which is lovely. That's set to 60 frames per second. Let's play that. And it will save at the last frame. Now let's jump back into Unreal. We'll just drop down a basic level and then open the USD stage. There's our flag. It's halfway in the ground. Zoom out of there a bit. So first thing to check, is it animated? Close that up a bit. Select the stage actor and we'll just focus on it so it's a bit easier to see. Look at its sequencer. Did that work? It did. And I'm just going to turn on my frames per second here. Like that. There we go. And let's press play. A lot more stable, a lot faster, and reporting 60 frames per second. That's how you get Vertex animation out to Unreal. It's also the difference between Vertex animation and skeletal animation. Where to from here? This is how Vertex animation works. Game engine. This is how game engine Vertex animation works. And USD literally saves every single thing, every single frame, and everything that you animated. From here is that you need to tell USD that it is animated, and you do that in use frame and by connecting the frames up to the frame here. Now this works for everything. If you wanted to say animate your texture, if you've got an animated vertex color here, which you can absolutely do, you can see that the define attribute also has use frame and frame number. So anything like that will completely work and can be animated. So like I said, this is all about, I don't need that anymore. This was leading you into making a tool. I'm not going to make it for you, but I'm going to leave this here. So USD animated mesh. Let's hook that back up the way it was. So we'll have a stage. We'll hook in the stage there. We'll break that. Let's find our cache. That's that. That goes into there. So it's all a lot easier when you've got a tool set up, isn't it? You've got a Vertex color ramp. We can put that in there. And then we will save this as Vertex animation 001 just for smartness. And then we can just delete what we've done. So if you wanted to open Vertex animation, that would work. That'll show you it all broken down. If you want to open this one, it'll show you how it was at the beginning. So I'm going to take away all of that, like so. I'm going to go in here, I'm going to delete that guy. Don't forget, you might have to change where the cache is coming from, because this is my folder, but I am going to give you the Bob cache folder in with the file so that you can play with it. And then we just need we don't need a string, that's for sure. We just need an output here. So this is the tool version, right? Let's turn on use texture. Let's make sure that we're showing textures. There we go. Let's pump this light up a little bit so we can see what's going on. So this is the Vertex animation 001 file. This is everything we just did, but set up as a tool with logic and things like that. So I'll need to hook up my mesh to my ramp if I want to get ramps. There's a nice little example of how to make a ramp here. And now if I turn off the texture, I've got the ramp texture coming through. And that will write out to you to Unreal as well. You've got your output in this location, your mesh name, all of that kind of thing. All of your bind materials, etc. are set up for you in here already. This is basically just what we did to start with. There's the metadata, setting the frames per second, which comes from the FPS here. Number of frames, output unit size in meters, all of that good stuff. So that's the end of this bit of the session. We're going to go into we're just going to take it a little bit further now and talk about how we can build something that will act as a bridge between Bifrost and Unreal Engine specifically. It's not really a bridge, and you can see that straight away, because if I was to say, take this guy, grab that and overwrite what we were doing there, play that through, just so it saves the animation. Again, it'll save the animation at the end. See it pause for a second there. Jump back into Unreal, go into USD stage and reload it. That's why it's not a bridge. So I've got a feeling I've grabbed the wrong Unreal. So let's just delete the USD stage. Goodbye. Go to the USD file, open it, grab that guy. So this is sometimes you have to do that. There's the ramp that we had, and it's all good. And it'll have a sequencer on the USD stage actor. Again, not my job to teach you Unreal, but our sequences come through correct. It's not crashing when you scrub. There you go. And that is real. I found that was really just setting the frames per second fixed that. It still occasionally falls over, but not very often. This is not a bridge because of one thing. So let's say I want to use the texture. Okay. I have to go back into Bifrost. I have to play it through again to get it to save. Come back into Unreal and reload it. And there's our textured version of the same animation, right? That's why it's not a bridge, because if it was a bridge, I would change it here. It would show up here. If anybody's feeling like a really good blueprint challenge, you could get into the USD plugin that Unreal uses and get it to be a bridge. But it's very close to one. And it's very close to one, especially for authoring assets, look deving really quickly, stuff like that. So what I'm going to show you is not a bridge, but it is, let's call it the foundations of a bridge. It's where we can start. That makes going from Maya and Bifrost specifically. So all of the power that Bifrost brings to this, the NPM, this is NPM cloth I'm using here, all of the logic and the procedural stuff that you can do in Bifrost, all of the scattering stuff you can do in Bifrost, it makes it easy to go from Bifrost to a game engine, rather than the old way where you would have to set that up all in Maya to do it Maya's way, export that as an FBX. With this system, you can do this, save the USD file, and load the USD file in Unreal. Your textures will come through, your all of your vertex will come through, vertex animation if you've got it, your placement, your instances. It's just a lot faster than building each asset separately in Maya, exporting as an FBX, bringing it into Unreal, doing some layout, going back to Maya, building the next asset, and so on and so on and so on. So as a tech artistry thing, this is technically not a bridge, but it is a start. So let's get on with that.